Hello everyone, in the lecture series of digital electronics, and today's topic is 1-bit memory cell, flip-flops and latches. Simple introduction of flip-flop and latches. First thing is 1-bit memory cell, or we can say basic bistable element. Here you can see the block diagram of 1-bit memory cell. As you can see here that it has two states, that is Q and Q bar. So because of these states, either it is a 1 or 0, it is called as basic bistable element. It has two inverters, 1 and 2. So these inverters are connected in cross coupled structure. Cross coupled structure means that output of first input A is going to be connect at input second, okay, and output of second input is going to be connect at input 1. So this overall structure is called cross coupled structure. So suppose we are taking at A input 1, so inverter 1 output is 0, so Q is equals to 0. This 0 value is going at B side, so B is equals to 0. Okay, so B is 0, so second inverter output Q bar is equals to 1. So we have output Q and Q bar, that is 0 or 1. 0 or 1, and suppose at A we have 0 as a input, so Q is equals to 1, and same is going at B, that is 1 here, so output of this inverter 2 is at 0. So again we are saying that this is a bistable element because of two stable states, that are logic 0 and logic 1. Here are the key points of this bistable element, that the two outputs are always complementary to each other. The circuit has two stable states. When Q is equals to 1, it is saying that set state. When Q is equals to 0, it is a reset state. The circuit can store 1 bit of digital information, so it is called 1-bit memory cell. As we have seen in this block diagram, that it can store only 1 bit at a time, like either it is 0 or 1. That's why it is called as 1-bit memory cell. Now what is latch? The 1-bit information stored in the circuit is logged or latched in the circuit. This circuit is also called latch. Now, what are latches? A latch is an example of a bistable multivibrator, that is a device with exactly two stable states. These states are high output and low output, logic 1 or logic 0. A latch has a feedback path, so information can be retained by the device. So as you can see here, that its output is connected at input side, so this is feedback. So a latch is a device which connected in feedback condition and with cross coupled structure. Latches are very similar to flip-flops but are not synchronous devices and do not operate on clock edges as flip-flops do. So another term is coming here, that is flip-flop. We will see this flip-flop in further slides. What is flip-flop? Flip-flop working is similar to latches, but the difference is clock. Okay, here one term is coming, that is synchronous devices. We know there are two types of devices, that is asynchronous and another one is synchronous. Synchronous depends on clock input, but there is no clock input in asynchronous devices. Okay, so flip-flops has same block diagram with clock signal as a input. So we can say these are in it is a basic storage element in sequential logic. So what are the differences between latches and flip-flops? Both are the building blocks of sequential circuits. Latches can be built from gates and flip-flops can be built from latches. Okay, latch does not have a clock signal, but a flip-flop always have a clock signal. Uses of these flip-flops. As latches and flip-flops are used to storage 1-bit element, so we can use these flip-flops and latches in memories, registers, RAM, etc. Flip-flops can be used to store 1-bit or binary digit of data. The data may represent the state of a sequencer, the value of a counter, etc. So that's all for today in this video. Thank you.